We've talked about the sine, the cosine, and tangent of special angles. Now we're going to talk about multiples of those. So a 30-degree angle. First quadrant, 30 degrees. The sine of that angle. We talked about the relationships of each of the sides. We know that the sine, if we draw it within a unit circle, the sine of 30 is 1/2. So the y value is 1/2. The sine represents the y value. So if we have an angle of 150 degrees, right, so here's your point, 1/2. If we have an angle of 150 degrees, and we want to find the sine of that angle, well, if this is 150, this angle here is 30. So isn't the y value of this the same as the y value of this? 1/2. In other words, the sine of 30 degrees is equal to the sine of 150 degrees, which is 1/2. And that's because the sine is the y value, and the y values are the same for 30 degrees and 150 degrees. So we're going to talk about how to find these for other angles and how to find the sine of 30 in the first quadrant. Look at 150, where the remaining angle is 30 in the second quadrant. In the third quadrant, we can talk about, again, another angle of 30, but the total angle of 210 degrees. And the same thing in the fourth quadrant. So flip to the next page. The first thing we have to learn about is reference angles. So a reference angle is the angle between the terminal side and the x-axis. Don't ever measure to the y-axis. So in the first quadrant, it's just going to be whatever you get. So example, 30 degrees, just 30 degrees. In the second quadrant, you're going to take the angle, whatever the angle happens to be, and subtract it from 180, and then you'll get the reference angle, the angle between the x-axis and the terminal side of the angle. Third quadrant. Here's your angle here all the way around. To find this one, you're going to take the angle and subtract it from 180. And in the fourth quadrant. So you're always measuring the angle from the x-axis to the terminal side. 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 So let's find reference angles. .45 degrees. .45 degrees. So the reference angle, if it's in the first quadrant, is the same answer. The measure of the angle from the x-axis to the terminal side is 45 degrees. Reference angle for 120. It's over here somewhere. The reference angle is the measure of the angle from the x-axis to the terminal side of the angle. So if this is 120, what's this? Well, halfway around the circle, 180 degrees. So if it's 180 to here, 120 to here, the difference here is 60 degrees. So the reference angle is 60. Next one, 215. 215 is from here all the way into the third quadrant. Again, to find the reference angle, we're going to measure this angle right here. End of the angle, back to the x-axis. Remember, never go to the y. So if this is 180 and this is 215, the difference is your reference angle. So this angle here, 35 degrees, is your reference angle. The next one, 280. 270, 3/4 of the way around. So 280s just pass into the fourth quadrant. So again, reference angle, go back to the x-axis, the closest x-axis, right here. Notice all of these are less than 90. Any reference angle is less than 90. So if this is 280, all the way around is 360. So 360 minus 280. So this angle here measures 80 degrees. Negative 60. Remember, negative means opposite direction. Reference angles are always going to be stated as a positive. So negative 60 is here. The reference angle is the measure of that same angle from the terminal side back to the x-axis. However, we always state it as a positive. So the reference angle for a negative 60 is 60. Negative 140. Again, you're going to measure here. Negative going clockwise. Reference angle from that side back to the x-axis. This is 180. 180 minus 40, 140 is 40 degrees. Notice always positive. Notice always less than 90. Okay, the next page. Remember how we talked about the two special triangles and using the unit circle to help us find the sine, the cosine, the tangent, and the reciprocal functions. We're going to use that same concept to find these answers, which are multiples of those angles. So again, you can have memorized the sine, the cosine, the tangent of 30, 40, 60, 90, 180, 270, or you can use those triangles. So I'm going to call this one my 30, 60, 90. Across from the 30 is 1. Hypotenuse is 2. Square root of 3. This one's my 45, 45, 90. Legs are both 1. Hypotenuse is the square root of 2. Let's do the first one. Cosine of 30. Cosine is adjacent over hypotenuse. Straightforward. Cosine of 135. What we're going to do now is use the concept of these triangles and also the reference angle. So let's talk about where 135 is. 135 is in the second quadrant. Remember, all students take calculus? What's the reference angle for 135? What's this angle? If this is 135, all the way over is 180. 180 minus 35, this angle is 45. So you're going to say, what's your reference angle? 45. Then the next thing you're going to say is it positive or negative in that quadrant? We're talking about the cosine. In the second quadrant, sine is positive, therefore cosine is negative. So the cosine of 135 degrees is equivalent to the negative cosine of 45 degrees. And again, it's because the distances, the x here, because we're talking about cosine, is the same as in the first quadrant if we had drawn an angle of 45 degrees in that quadrant. It's the same value. Just like this point was xy, this was negative xy, it's the same distances, the signs just change. So what's the cosine of 45? You can go to your triangle, adjacent over hypotenuse, rationalize it, or memorize the answer. Either way, you get negative square root of 2 over 2. Secant of 45. Cosine is adjacent over hypotenuse, so the secant is the reciprocal of cosine. So it's square root of 2 over 1. Just call it the square root of 2. So if it's in the first quadrant, those are easy. Those are the ones we did the other day. Now again, let's talk about one that's a multiple. This one's a multiple of 60. Go back to the concept of reference angles. (240 degrees) is in the third quadrant. The reference angle is 60 degrees because it's 180 to here, 240 to here, the difference is 60. So the sine of 240 is the y value here, which is same as the y value here if this were 60 degrees. So the sine of 240 is equivalent to the sine of 60. We have to talk about, is it positive or negative? In the third quadrant, tangent is positive, which means that sine and cosine are negative. So the sine is going to be negative in the third quadrant. So the sine of 240 degrees is equal to the sine of 60 degrees. Sine of 60, memorize or go to your triangle. Sine is opposite over hypotenuse, so our answer is negative square root of 3 over 2. Tangent of 210. What quadrant is 210 in? What's your reference angle? Your reference angle is 30. Tangent, third quadrant, positive or negative? The answer is positive. So the tangent of 210 is the same as the positive tangent of 30. Go to your triangle, opposite over adjacent, rationalize, square root of 3 over 3. Now, when we do the reciprocal functions, we're going to work with the reciprocal first. Cosecant of 120, you're going to think about which does that go with. It goes with sine. 120, what's your reference angle? 120 is here. What's your reference angle? 180 minus 120, 60. Second quadrant, positive or negative? Positive. So remember, this is the reciprocal. Cosecant of 120 is the reciprocal of sine of 60. Well, what's the sine of 60? Go to your 60, opposite over hypotenuse. So square root of 3 over 2. So go the other way, 2 over the square root of 3. Then we have to rationalize it. Shouldn't be. Rationalize it, 2 square roots of 3 over 3. Last one. Negative 240. Negative 240. 180. Reference angle 60. Cotangent goes with tangent. So it's the reciprocal of tangent of 60. Positive or negative in the second quadrant? Negative. Tangent of 60. Opposite over adjacent. So square root of 3 over 1, but we're going to flip it. So 1 over the square root of 3. And of course negative, because we're in the second quadrant. Rationalize. So what are our steps to finding these values without a calculator, and why shouldn't I use a calculator? If you get an answer like 1/2, the calculator's fine. But these all have radicals in it, and when you're looking for exact values, you can't use the calculator. So you're going to ask yourself, what's my reference angle? What quadrant am I in? And then evaluate. So reference angle, positive or negative, and then evaluate. If it's a reciprocal function like cosecant or cotangent, you do all these steps, but then when you evaluate, we flip it, we take the reciprocal. Okay? So you want to make sure that you know how to find a reference angle. X-axis, terminal side. Here, 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 or here. Answer's always positive and always less than 90. Make sure you know your reciprocal functions. Secant goes with cosine. Tangent goes with cotangent. Cosecant goes with sine. If you don't memorize your basic angles, then you need to memorize the triangles and be able to use those. And remember your SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And be able to evaluate them or take the reciprocal. And also rationalize denominators when necessary. This is something almost like when you learned your multiplication facts that you need to do repetitively in order to be able to come up with the answers quickly.